So hylozoism is a lovely word from the ancient Greek, which means life coming out of material, making an active circulation system that functions much like the lymph system in your own body. Dozens and dozens of glass flasks. All of that is working together with a very gentle, slow system of active chemistry.
Things that have minimum surfaces, things that have maximum amounts of territory. The rather symphonic work that was produced for the Canadian Pavilion in Venice, multiple layers, hyperbolic scaffolds, distributed computation, synthetic biology woven in, and a turf-like amalgam weeds clothing the surface in order to search for a new kind of fabric for architecture. This kind of architecture behaved very, very well. It was tenacious, it stood up, it engendered a kind of stewardship and care that suggested that collective energy need not only be founded on security and on solid ground and on boundaries. Rather, a very careful kind of fragility might contribute to a social realm. All of those technical systems then are woven together in a way that is deeply empathetic, that depends on human experience, and that fosters conversations back and forth. And so in the end, while the work is intensely technical, it also is founded on a kind of philosophy where we're seeking mutual relationships with the world, being among, being interdependent, even being unapologetically fragile, rather than trying to command and control and govern. On integrating electronics with the structural systems that I've been describing, the kind of resilient scaffolds. A rather traditional relationship of electronic controls with structures is that of a cluster, let's say the same kind of thing that we have in our cranium, separate from our body. What about if instead of those kind of consolidated, powerful groups of controls, we could think of a kind of environment as having a whole meshwork where many, many different nodes are all speaking to each other. We've started to look at the way nature works in wetlands, or the way deep filaments intertwine in a mycelium, that is a mushroom root network. And that translates into a wish to find a new kind of electronics. Rather than concentrated printed control boards, we're looking for ways to take very small, gentle elements and distribute them. And so we might have, rather than moving from these rather modest microprocessors, we're very interested in moving with increasing miniaturization into elements that can be directly integrated into mechanisms. And so we're quite excited about the possibility, this is just a prototype board that we've just developed, about integrating some quite meticulous detailing into the board itself. Elective circuitry that we can quickly go through multiple prototypes with, and then at the same time look at the kind of strain relief or the clipping or the cable mounting, perhaps even going into soft substrates so that this then could move and shift. You can see that the organization is one of computationally derived scaffolds, quite carefully tuned, using digital fabrication that makes a fundamental textile-like structure. Now, woven into those is a whole manifold of glassworks, which then has liquid chemistries let into them, seeking to invest this work with a primary kind of synthetic metabolism.